Dr. Bodez.
Hey, Tyler.
It's really hot today. Do you know what I wish I had some of?
Some ice, baby.
Some ice, baby.
So, welcome to the pre-class video on some calculations with equilibrium constants. And we're introducing a really important tool for you today. This is a tool that you're going to use, you're going to love, called the ice table.
Yeah.
Yeah, and it's used for solving lots of different types of equilibrium problems. And the structure is pretty simple. So, to use the ice table, I always set up the balanced equation on the top. Write out the balanced equation. Here we have a typical balanced equation. Sulfur trioxide reacts to form sulfur dioxide and oxygen. And there's a nice stoichiometry. And there are 3 rows on the ice table. We got our initial, our change, and our equilibrium, ICE. This is going to help us organize the information for these problems, right? So, for example, I could say we put into a flask 0.002 moles of SO3, or molarity SO3.
Okay, so that means we're starting with it.
Right.
Initially.
Initial. 0.0200 molar. And if I don't say anything about the other reactants, or the other things in this equation, that means that they're probably starting off
at 0.
At 0. If I say I fill the flask with this, and I don't mention anything else, that's what's in the flask. The key to the ice table is really this change row. And this change row is going to allow us to relate what happens to one thing to what happens to the other things in the balanced equation. Yeah. And I'm going to just put in variables there.
Okay, because we don't know what the change is yet.
Not necessarily. Sometimes you will. Sometimes you'll actually be told the change of this one is, of O2 is is 0.2.
That'd be nice.
Yeah. But this will allow us to relate the change of one thing to the change of another. And the way you do it is you put the coefficient from the balanced equation, a 2, and then an unknown, x. The other thing is that if I think that a concentration is going to decrease, I put a negative sign there.
Right.
If I think it's going to increase, I leave it as a positive. Well, since there's none of these, I'm pretty sure that I'm going to use up this, so I'm going to put a negative there.
Right.
Well, if this changes by negative 2x, how is this going to change?
Well, it's in a flask, so it's not going anywhere. So if that loses 2x, this should gain 2x, and so should this. Well, actually, no, just kidding.
Not quite. Exactly, it's tied by the stoichiometry. If this decreases by 2x, this is going to increase by 2x. And this is only going to increase by 1x.
Right, and that's because it takes 2 moles of sulfur trioxide to get 1 mole of oxygen.
Right. And so, kind of makes sense.
Right.
So it doesn't matter if you put a negative or a positive here first, and actually it really doesn't matter. The math will actually work out. But what is critical is that they have opposite signs. Reactants and products have to have opposite signs.
Right.
Okay. Well, what about the equilibrium? Well, if I started with this one and it changed by that, in equilibrium, what do I have?
The addition of those 2 together.
Yeah. Just add these 2 together, and you get 0.0200 minus 2x molar. His were easy because he added to 0, right?
It's tough sometimes.
Right? And so we have this all filled out before I have any additional information to actually use this, and probably you need at least one more piece of information.
Your K.
You could know your K. You could be given K, and then you could solve, set up an equation. K equals, let me see, SO2 squared O2 over SO3 squared. And then I could plug in the values now for equilibrium, because these are at equilibrium. And I could say 2x squared x over 0.0200 minus x, minus 2x squared.
There you go.
Right? And if I know k, this becomes one equation with one unknown.
Right, and you solve for x.
You solve for x. Or I could be given a final concentration. Maybe they tell me what the final concentration of oxygen is. Well,
So you could erase this and put a number in
yeah, I could say x equals that concentration. Well, then I know what 2x is, then I know what 0.02 minus 2x is, and I could actually plug those then into this equation and calculate what a k is. So you can use it in a lot of different ways. I think generally you need to either have an equilibrium constant or have either one row or one column completely filled out.
With numbers,
With
no
numbers.
variables.
With no exactly. But, so this is really to introduce you to this idea because it's important that you be able to understand this and use it. So thinking a little bit about it ahead of class will be a very good thing. See you in class.